Next concept is law of mass action for semiconductors. So we have the equation for electron concentration and hole concentration. First write down the expression for Ne and NH. So by these two expressions we see that the dependence of both Ne and NH on Fermi energy. So now let us find out the product of Ne and NH, that is equals to 32 divided by H6 into pi kt cube into Me star mh square whole power of 3 by 2 e to the power of Eg by kt is the product of Ne and NH. So this shows that the product of Ne and NH does not depend on EF, but it remains constant at a given temperature. Therefore, Ne into NH is equals to a constant. So this condition is applicable for both intrinsic and extrinsic semiconductors, as the equation for Ne and NH are same in both the cases. So therefore the above equation is called as law of mass action for semiconductor, which says that for a given semiconductor material which is either intrinsic or extrinsic, the product of the charge carrier concentration remains constant at any given temperature, even when the doping is varied. So in case of the intrinsic semiconductor, we can write it as Ne is equals to NH is equals to Ni. So Ni is your intrinsic charge carrier density. So now let's move towards the derivation of expression for electrical conductivity in case of semiconductors. So on the basis of free electron theory, the charge carriers can be assumed to be moving freely inside a semiconductor. That means both electrons and holes contribute to the conductivity of semiconductor.